Hello, this video is for IXL Activity A1.C.7. It's titled Scale Drawings, and they are indeed word problems. The 3-character code for this activity is 8 Bravo 7. So our first question is, Brian made a scale drawing of a neighborhood park. A soccer field in the park is 18 inches long in the drawing. The actual field is 90 yards long. What is the scale of the drawing? So in this, we want to approach this a couple ways. Actually, we'll use proportions, and then we'll look at another way of doing it as well. So if I want to use proportions for this, and remember, a proportion is that A is to B as C is to D, where I have two ratios that are set equal to one another, going to be missing one value, and then we're going to solve for that value. So how could we set this up? Well, we could say that 18 inches is to 90 yards. So 18 inches is to 90 yards. We'll do YRD. And now we want inches to yards again. Making sure that our measurements, if we use inches in the numerator, the inches stays in the numerator, and yards we use in the denominator, so we'll keep it in the denominator. Now, we want to compare that to 1 inch is equal to, and we're missing the number of yards here. So, on the left is kind of what we have in real life. This is the real life situation over here. And where over here, this is the scale. So, indeed, we're looking for what is the scale. And we're missing the number of yards. So, we can do cross products of 18 times x is 18x. Set that equal to 90 times 1, in this case is 90, and then dividing both sides by 18, 90 divided by 18 should be, I believe, 5. Yep, 5 times 18 is 90, 50 plus 40 is 90, indeed it is. So the answer is going to be 5. So in this case, 1 inch is to 5 yards. Now, another way that you could have done this, if you wanted to, is you could have said, okay, I got 18 inches is to 90 yards. And you could have said, okay, to get from 18 to 1, I would have to divide by 18, right, to get from 18 to 1. So to get, so if I divide 18 by 18 to get to 1, then 90 divided by 18 would give you 5. So either way, whether you want to set it up using this process that I've used here, over here, or whether you want to use proportions, either one will work. Rudy measured a neighborhood park and made a scale drawing. In real life, the volleyball court is 16 meters long. It's 40 centimeters long in the drawing. What is the scale of the drawing? So over here we're going to have real life, and then over here we're going to have the scale. So in real life, 40 centimeters, and I always like to put the smaller measurement here, 40 centimeters, is to 16 meters. Because centimeters are smaller than meters. We'll set that equal to centimeters to meters here. And notice that it's always the smaller measurement here that comes first. Centimeters being less than a meter. And 5 is to x. 5 is to x. So we do 40 times x is 40x. 16 times 5 is 80, correct? Divide both sides by 40, and we get x is equal to 2. So in this case, it would be 5 centimeters is to 2 meters. Now again, we could have taken the 40 centimeters here and kind of lined it up here. 40 centimeters is to, and we have 16 meters. Well, to get from 40 to 5, we have to divide by 8, and 16 divided by 8 is 2. Carrie made a scale drawing of a swimming pool. The scale she used was 6 centimeters is to 5 meters. The pool is 18 centimeters in the drawing. How wide is the actual pool? So this time, if we put the real life over here and the scale over here, we're going to find that what we're missing is our value that's in one of our values from over here on the left with the real world situation. Because they tell us that the scale is 6 centimeters is to 5 meters. And then over here we want centimeters at the top. in meters at the bottom. So they give us the 18 centimeters here. And the meters is what we don't know. And it's on the real life side. So how wide is the actual pool? So the actual pool is the real life side. So with that said, 18 times 5 should be 90. And we're going to set that equal to 6x. And then divide both sides by 6. And that should be 10 of them to get you to 60, 30, 15. Yep, x equals 15 meters. Now another way you could have done that is you could have taken the scale, 6 centimeters is to 5 meters, and then which one do they give us? They give us the 18 centimeters. So the question is x number of meters. So 6 times 3 is 18, so 5 times 3 would be 15. Lexi drew a scale drawing of a house and its lot. The scale she used was 2 inches is to 1 foot. If the actual width of the house's driveway is 17 feet, how wide is the driveway in the drawing? So again, let's have real life over here and the scale over here. Set these two ratios equal to one another. Inches to feet. So go inches in the numerator, feet in the denominator. They tell us that the scale is 2 inches to 1 foot. And so we're missing something over here in the actual, that's actually real life. Sorry, let's go back. Can I squeeze that circle in there? Outstanding. In the scale over here is 2 inches to 1 foot. There we go. And they're telling us that if the actual width of the house is 17 feet, so 17 is the number we have here, so we're missing inches here. So we could actually find out how wide the driveway is in real life by doing this proportion. So 1 times x is x, and 17 times 2 is so it's 34. All right, yep. So I end up with 34 inches. Now I could have done this as 2 inches is to 1 foot. And then we would have this set up here. They give us the 17 feet. And so the question is how many inches? So in this case, to go from 1 to 17, we had to multiply times 17. And 2 times 17 is 34. All right, in the next question, Richard measured a city and made a scale drawing. The scale of the drawing was 1 inches is to 2 yards. A neighborhood park is 54 inches in the drawing. How long is the actual park? So we got real life here. We have the scale here. Set that up. Let's see what our measurements are. The scale is 1 inch is to 2 yards in the scale. So 1 inch to yards. And that is 1 inch to 2 yards. So let's put inches here and yards here. Now they're giving us the inches, which is 54. Now we can go ahead and solve for the number of yards. 54 times 2 is 108. And 1 times x is just x, so we know that it's 108 yards. If we wanted to do it the other way, we could set the scale up of 1 inch is to 2 yards. And then we could compare that to the ratio of inches they give us, 54. And so it is x number of yards. So we look at what do we do to get from 1 to 54? Well, we had to multiply times 54. And 2 times 54 is indeed 108. Okay, now they're asking for something different. Now they're asking for a scale factor. Darnell drew a scale drawing of a city park. He used the scale 3 centimeters equals 1 meter. What is the scale factor of the drawing? So scale factors just use numbers, no measurement abbreviations. Like here, let's go back and take a look at some of these here. Here we had 5 centimeters is to 2 meters, where in this case we had centimeters and we had meters. Now we're going after something that looks just like, we're just going to have A is to B, where we have 2 values and we have a colon. So with that said, well, if we're going to get rid of the measurements, then chances are that each of those numbers pretty much have to be the same measurement, right? So let's go ahead and go with that idea. So 3 centimeters is to 1 meter. So do 3 centimeters is to 1 meter. Well, we want them both in centimeters. So let's do 3 centimeters is to, and this case, how many centimeters are in a meter? Well, there are 100 centimeters in a meter. So instead of 1 meter, let's do this. 1 meter is equal to 100 centimeters. So instead of putting 1 meter in there, we're going to put 100 centimeters in. 100 centimeters. Now, in this case, we have now set up a situation where our measurement's the same, so we can just compare the numbers. 3 is to 100. So the idea is that we want to convert the larger measurement to the smaller measurement using an equivalent amount. So I don't know if I worded that very well, but we're going to do plenty of examples to get an idea of how that works. Jamal drew a scale drawing in the high school. He used the scale 9 millimeters equals 3 meters. What is the scale factor of the drawing? So let's go 9 millimeters equals 3 meters. And that's millimeters, mm. So let's go ahead over here to the side and do 3 meters is equal to how many millimeters? Well, 1 meter is equal to 1,000 millimeters, or 1,000 millimeters in a meter. But we have 3 meters, so that means that we must have 3,000 millimeters. So it becomes 9 millimeters is equal to 3,000 meters, or millimeters. So now we can just compare 9 to 3 and have that there of 9 millimeters is to 3 millimeters. However, it says to simplify your answer, and we want to simplify this 9 to 3. Well, remember, we could write a ratio as a fraction. So 9 is to 3, right? Well, if I simplify this, both these will divide by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So we could rewrite this 9 over 3 can be simplified to 3 over 1. And if I write that as a ratio, end up with 3 to 1. So this would be our final answer, 3 to 1. On the first problem here, 3 and 100 share no common factor, so it was already simplified. So 3 to 100 was already simplified. But yet whenever we get over here, 9 to 3, well, 9 and 3 both share a common factor, so we could simplify that down to 3 to 1. Gina drew a scale drawing of a city. The scale she used was 1 inch equals 1 yard. What is the scale factor of the drawing? So 1 inch is to 1 yard. Well, what we know about yards is that 1 yard is equal to 3 feet, right? But that doesn't do us much good. We actually have to get to inches, correct? So, and then 3 feet. I'll go back. So let's go with this. Now, what do we know about feet? So we know that in 1 foot is equal to 12 inches. So if we have 3 feet, then it must be 12 times 3, right? So we're going to get 36 inches. There's 36 inches in 3 feet. So 1 yard equals 36 inches right there. So 1 inch, and now 1 yard, we're going to rewrite as 36 inches. Now we can just use the numbers. 1 is to 36. And it's already simplified. 1 and 36 share no common factors except for 1. So we're pretty much simplified already. Noah drew a scale of a drawing of the auditorium. In real life, the stage is 60 feet long. It is 3 inches long in the drawing. what is the scale factor of the drawing? So we have 3 inches, always use the smaller size first, is equal to 60 feet. But we need to get 60 feet to inches, correct? We want to know 3 inches equals how many, and we want both measurements in inches. Well, in 1 foot equals 12 inches. So that means, but I have 60 feet, so I must need to multiply 12 times 60. And let's do this. Let's do 12. Let's take the 0 off the 6, throw it to the side. Let's do 12 times 6. That's what, 72? Now let's throw that 0 back on. So hopefully you kind of understand my mental math there. 720 inches should be correct. 12 times 6. And just to keep all of us happy, I'm pretty sure that 12 times 60 equals 720. Indeed it does. So now I can go ahead and write this as 3 is to 720. However, I know that 720 is divisible by 3. How do I know that? I know that because 7 plus 2 plus 0 equals 9. 9 will divide by 3, so 720 will divide by 3. So 3 divided by 3 is 1, and 720, we'll go ahead and do that with the good old algorithm here. 3 goes into 7 twice, 6, 1, bring down to 2, 3 goes into 12, 4 times, and 12, 0, I still have this 0 here, 240. So 720 divided by 3 is 240. So I got from here to here by dividing both of the values here by 3, because 3 and 720 are both divisible by 3. So it simplifies to 1 is to 240. Next question. Sophia made a scale drawing of a house. In real life, the hall closet is 4 feet wide. It's 8 inches wide in the drawing. What scale factor does she use? So inches is smaller than feet, so I'm going to start with inches. 8 inches equals 4 feet. Now I need to get them both to inches. So let's go ahead and convert 4 feet to inches. So both of the values are in inches. Both measurements are in inches, not one in inches, the other in feet. So in 1 foot, there are 12 inches. I have 4 feet, so I need to multiply 12 times 4. And that's going to be 48. So I have 48 inches inside of 4 feet. Now I can write this as 8 is to 48, since they're both in the same measurement. And 48 and 8 both share a common factor, and that factor is 8. So 8 divided by 8 is 1. 48 divided by 8 is 6. So the answer is 1 to 6. Be sure to simplify. Once you get to this answer here, if it can be simplified, if both those values, the values on each side of the colon share a common factor that they can be divided evenly by, then you need to do that in order to simplify it. Otherwise, they will mark it as incorrect. Sasha measured the middle school and made a scale drawing. In real life, the gym is 66 feet wide. It is 66 inches wide in the drawing. What is the scale factor? So I have 6 inches, and that is equal to 66 feet. I need to get to feet from inches, so 1 foot is equal to 12 inches. So I need to multiply 66 by 12. And I think just for the fun of it, I'm going to use a calculator this time. Save time. 66 times 12. 792. So with that said, I end up with 6 inches equals 792 inches. Converted the 66 feet to 792 inches. So I can now write it as 6 is to 792. Now if I'm using a calculator, right now I got 792 in my calculator, and I'm wondering, is that divisible by 6? So I just do divide by 6, and sure enough, it is. 792 divided by 6 is going to give me 132. and 6 divided by 6 is 1. So it's going to be 1 is to 132. Now, I could have checked using divisibility rules for this. Let me see, 7 plus 9 plus 2 equals, was it 11 equals 18? Is it? Yep. And 18 is divisible by 3. Correct? So 792 would divide by 3. And since it is an even number, 792 ends in the even number, it's divisible by 2. So the rule for 2 works, rule for 3 works, therefore I would have known that the rule for 6 works. But since I had 792 in the calculator, it was easier to just go ahead and type in divided by 6 and see if indeed I come up with a whole number. And indeed, as you can see, I do. So let's go ahead and move on. Hopefully there's just one more. How many? Yep, final question. Ashley measured a petting zoo and made a scale drawing. She used the scale 6 millimeters equals 1 meter. What scale factor does the drawing use? So we're going to go ahead and take 6 millimeters and say that that's equal to 1 meter. So we want it in 6 millimeters equals, and we want 1 meter in the form of millimeters. Well, 1 meter is equal to 1,000 millimeters. There are 1,000 millimeters in a meter. You can always Google that for metric system conversions. So 1,000 millimeters in 1 meter. So I now have 6. 6 equals 1,000. No, that's not what I want. I don't want an equal sign. I'm already trying. My brain is thinking ahead. Well, let's simplify. Is 1,000 divisible by 6? And not sure. I don't believe it is. 1,000 divided by 6. No, it doesn't work because the rule for 2 worked, but I knew the rule for 3 wouldn't work, so the rule for 6 wouldn't work. However, they are divisible by 2, right? They're both even numbers. 6 divided by 2 is 3, and 1,000 divided by 2 is 500. Now at this point, 3 is only divisible by 3, and 500 is not going to divide by 3. So I am all the way down to 3 is to 500. All right. So those are all of my examples for IXL Activity A1.C.7 Scale Drawing Word Problems. Good luck with your activity.